What if the secrets of the universe weren't discovered in a modern lab, but whispered in ancient texts thousands of years ago? Picture this: centuries before quantum physics became a cornerstone of science, sages in India were already describing realities that mirror our most cutting-edge discoveries today. The Vedas and Upanishads, sacred Hindu scriptures, speak of a cosmic interconnectedness so profound it echoes the baffling phenomenon we now call quantum entanglement. How could ancient seers have envisioned a concept so advanced that even today's brightest minds grapple to explain it fully? Think about the last time you felt deeply connected to someone, like your emotions or thoughts were somehow tied to theirs, even across distances. Now imagine that same invisible thread binding every particle in the universe. That's quantum entanglement, particles linked in such a way that the state of one instantly influences the other, no matter how far apart they are. Einstein famously called it spooky action at a distance. But here's where it gets mind-blowing. Ancient Hindu texts describe this very idea using poetic yet precise language, framing existence as a web of inseparable relationships. The Rig Veda speaks of the golden womb of creation, where all things emerge from a single source, interconnected and interdependent. The Upanishads declare, Tat Tivam Asi, thou art that, a revelation that the self and the cosmos are not separate but deeply entwined. This isn't just coincidence, it's an invitation to explore a breathtaking possibility, that the rishis of antiquity might have glimpsed the fabric of reality through meditation and insight long before telescopes or particle colliders. Were they tapping into a universal truth that science is only now beginning to decode? Over the course of this journey, we'll unravel these parallels from the vibrational nature of reality described in the Vedas to the Upanishadic concept of non-duality, ideas that resonate uncannily with quantum theory. By the end, you won't just see these ancient texts as spiritual wisdom, you'll see them as a hidden blueprint of the universe itself. So let's dive in, because what you're about to discover might just change how you see everything. One of the most striking parallels between ancient Hindu thought and modern quantum physics lies in the concept of Akasha. The Vedas and Upanishads describe Akasha as the unseeable, all-pervading space, the invisible fabric of existence that holds everything together. But this isn't just empty space. Akasha is described as both nothingness and the womb of all potential, a paradox that eerily resembles what physicists now call the quantum vacuum. Today's science tells us that what looks like empty space is actually a seething ocean of virtual particles flashing in and out of existence, carrying infinite energy. The Chandogya Upanishad puts it this way: all that exists is born from Akasha, dissolves into Akasha, and is sustained by Akasha. Sound familiar? It's almost as if the ancients were describing the quantum field itself, the hidden layer of reality where particles emerge, interact, and vanish again. Take the idea of interconnectedness through Akasha. The ancient texts describe how everything from the stars to our thoughts vibrates within this shared medium, just as entangled particles remain linked no matter the distance. The Brihadaranyaka Upanishad declares, as the spider sends forth and draws in its thread, so the universe unfolds from the imperishable Akasha. Think about that image, a cosmic web where every strand is connected, where a single tug in one corner resonates everywhere. Quantum entanglement operates the same way. Change the state of one particle, and its partner instantaneously responds, defying our everyday notions of space and time. The rishis didn't need labs or equations to grasp this. Through deep meditation, they perceived reality as a dynamic, indivisible whole, a vision modern science is only now confirming. What's even more fascinating is how Akasha isn't just a passive backdrop. The texts describe it as alive with latent creativity, brimming with unmanifest possibilities. In quantum terms, we'd call this the zero-point field, the lowest energy state of the universe, which somehow still crackles with potential. The Taittiriya Upanishad compares Akasha to a hidden treasury, saying, "From joy all beings are born, by joy they grow, and to joy they return." Replace joy with energy, and you've got a poetic version of quantum fluctuations, the endless dance of particles arising from the vacuum itself. Whether through ancient wisdom or cutting-edge experiments, the message is the same. Reality is far stranger, far more connected than we ever imagined. Now let's turn to another profound parallel, the Hindu concept of Prakriti and the quantum fields that modern physicists study. In Sankhya philosophy, one of the oldest schools of Indian thought, Prakriti is described as the primal, dynamic substance of the universe, the unseen foundation from which all matter and energy arise. Unlike Akasha, which is the space that holds reality, Prakriti is the vibrant, ever-changing essence within it. The texts describe Prakriti as constantly vibrating, oscillating between states of potential and manifestation. And here's where it gets fascinating. This ancient idea mirrors the behavior of quantum fields, the invisible scaffolding of reality that physicists say gives birth to particles through ceaseless fluctuations. The Bhagavad Gita offers a vivid metaphor for Prakriti's transformations, comparing it to a woven cloth, threads of energy intertwining, dissolving, and reweaving themselves into new forms. This isn't just poetic imagery, it's shockingly close to how quantum fields operate. At the smallest scales, space isn't calm or empty. It's a bubbling sea of virtual particles popping in and out of existence in a frenzy of energy. Scientists call this quantum foam, and when you see animations of it, those shimmering, chaotic swirls of creation and destruction, it's hard not to think of the Gita's description of Prakriti's endless dance. But the connections go even deeper. Sankhya philosophy teaches that Prakriti's vibrations give rise to the tangible world through three fundamental qualities known as gunas: stability, activity, and inertia. These aren't just abstract ideas, they map eerily well to the forces and particles we observe in quantum physics. Take electrons, for example. They don't just sit still, they vibrate at specific frequencies, and their behavior shifts based on interactions with other particles. Prakriti's gunas seem to prefigure this dynamic interplay, suggesting that ancient sages intuited a universe built on relationships, not isolated objects. What's truly astonishing is how these texts describe transformation itself. The Upanishads say Prakriti is like a river, always flowing, never the same from one moment to the next. Quantum fields behave the same way. Particles aren't permanent, they're fleeting excitations of an underlying field, appearing and disappearing like ripples on water. When the Gita says, "All beings exist in Prakriti, and Prakriti is in all," it echoes the quantum view that everything, stars, trees, even our thoughts, arises from the same shimmering, interconnected web of energy. To hear Vedic chants alongside visualizations of quantum foam is to experience something uncanny, a harmony between ancient rhythm and modern science. The chants, with their precise vibrational patterns, seem to mirror the oscillations of quantum fields. It's as if the rishis encoded their understanding of reality's fabric into sound itself. Whether through sacred verse or mathematical equations, the message is clear. The universe is alive with motion, a symphony of vibrations where nothing is ever truly separate. The idea that reality might be an illusion isn't just the stuff of science fiction, it's a cornerstone of Hindu philosophy, and astonishingly, a fundamental principle of quantum physics. Advaita Vedanta, one of the most profound schools of Indian thought, teaches that the world we perceive is Maya, a cosmic illusion, a play of appearances masking the true, undivided nature of existence. The great sage Adi Shankara compared Maya to a rope mistaken for a snake in the dim light. Our senses deceive us, making us believe in separateness where there is only unity. Now hold that thought and leap forward 1,000 years to the lab of a quantum physicist. They'll tell you something eerily similar. Particles don't have definite states until we measure them. They exist in a haze of possibilities, a superposition of multiple realities, collapsing into one only when observed. This isn't just a quirky lab result, it's a mirror of Shankara's ancient warning that perception shapes reality. Take the famous double-slit experiment where particles act as both waves and particles until someone looks. The moment you observe, the wave function collapses and the particle chooses a path. Shankara's commentary on the Upanishads echoes this. The world is unreal, only Brahman is real. In other words, what we see is a flickering projection dependent on the observer, just like quantum systems. The parallels don't stop there. Maya isn't just about illusion, it's about the dynamic interplay of creation and concealment. The universe, according to Vedanta, is constantly projecting and dissolving forms, much like quantum fields generating and annihilating particles. The Mandukya Upanishad describes waking life as no more fundamentally real than a dream, a temporary configuration of consciousness. Compare that to how physicists describe particles, not as solid things, but as probability clouds, fleeting manifestations of an underlying field. Here's where it gets even more intriguing. Both traditions grapple with the same unsettling question. If reality is this fluid, what does that say about us? Quantum mechanics forces us to confront the idea that the observer isn't separate from the experiment. The act of looking changes what's seen. Advaita Vedanta takes this further. The observer, the observed, and the process of observation are all facets of the same divine consciousness, Brahman. When Shankara writes, "You are not the perceiver, but the very ground of perception," he's pointing to the same non-dual truth that quantum physicists stumble upon, an interconnectedness so deep it dissolves the boundaries between subject and object. The implications are staggering. If Maya teaches that form is emptiness and emptiness is form, quantum physics shows us that particles are waves and waves are particles. Both reveal a reality far stranger, far more malleable than our everyday experience suggests. The Taittiriya Upanishad says, "From terror of this, the wind blows, the sun burns." Replace terror with uncertainty, and you've got Heisenberg's principle in a nutshell. Maybe the rishis weren't just spinning metaphors. Maybe they were mapping the quantum nature of existence, a world where nothing is fixed until consciousness makes it so. Brahman isn't just a philosophical concept, it's the ultimate reality in Hindu thought, the unchanging, infinite ground of all existence. The Upanishads declare, Sarvam Khalvidam Brahma, all this is Brahman. Every particle, every galaxy, every fleeting thought is an expression of this singular consciousness. Now, place that idea beside modern physics' unified field theory, which seeks to describe all fundamental forces and particles as manifestations of one underlying field. The parallels are astonishing. Just as Brahman can't be divided or diminished, quantum entanglement shows us particles so deeply linked they act as a single entity, defying classical boundaries of space and time. Take the way the Upanishads describe Brahman's nature. It moves and it moves not. It is far and it is near. This isn't poetic ambiguity, it's a precise articulation of quantum non-locality, where particles influence each other instantaneously across vast distances. Einstein struggled with this, calling it spooky, but the rishis embraced it as fundamental truth. The Brihadaranyaka Upanishad states, "As a spider spins its web, Brahman projects the universe from itself." Replace Brahman with the quantum vacuum, and you've got a near-perfect metaphor for how modern physicists describe the universe emerging from a unified field. Even more striking is how both traditions grapple with paradox. Brahman is described as nirguna, without qualities, yet it's the source of all qualities. Similarly, the unified field in physics is an invisible, intangible matrix that somehow gives rise to everything from electrons to galaxies. The Chandogya Upanishad's famous instruction, Tat Tvamasi, or you are that collapses the illusion of separation, just as quantum entanglement collapses the illusion of independent particles. When two entangled electrons behave as one, regardless of distance, science echoes an ancient revelation. Duality is an illusion. Modern experiments only deepen the mystery. In quantum mechanics, particles exist in superposition until observed, their states undefined until consciousness interacts with them. Advaita Vedanta takes this further, proposing that consciousness itself is Brahman, the fabric of reality. The Mundaka Upanishad compares the universe to sparks flying from a fire, each spark seemingly separate yet inextricably tied to its source. Quantum fields behave the same way. What appears as distinct particles are mere excitations of an underlying wholeness. Perhaps most profound is how both traditions resolve the tension between unity and diversity. Brahman isn't a distant, abstract force. It's the very essence of every leaf, every star, every human thought. Similarly, the unified field doesn't erase individuality. It explains how infinite forms arise from a single source. The Taittiriya Upanishad likens creation to waves on an ocean, appearing distinct yet never separate from the water. Quantum physics agrees particles are transient ripples in an infinite sea of energy. What's exhilarating is that science is now venturing into territory the rishis mapped millennia ago. The unified field theory remains incomplete, but its pursuit mirrors the Upanishadic quest to know Brahman not through dogma, but through direct insight. When the ancient texts say, the knower of Brahman becomes Brahman, they're hinting at a truth quantum physicists glimpse in equations. To comprehend the universe is to realize you're woven into its very fabric. Whether through meditation or mathematics, the conclusion is the same. We're not just observers of reality, we're participants in its unfolding. The Rig Veda's Nasadiya Sukta, one of the oldest hymns known to humanity, opens with a question that still haunts physicists today. Who really knows? Who can proclaim it? Whence was it produced? Whence is this creation? This isn't just philosophical pondering, it's a startlingly prescient glimpse into the quantum realm. The hymn describes creation as a dance of that one tad ekam, a singular essence that divides into paired energies, moving in perfect harmony yet separated by vast cosmic distances. Sound familiar? Replace that one with entangled particles, and you've got a poetic blueprint for quantum entanglement. Take the image of two birds on a tree, found in both the Rig Veda and Mundaka Upanishad. One bird feasts on the fruit, representing individual experience, while the other watches silently, symbolizing pure consciousness. But here's the twist: these birds aren't just neighbors, they're inextricably linked. The texts describe them as reflections of a single reality, mirroring entangled particles that remain connected even when galaxies apart. Modern science frames this as quantum correlation, but the ancients called it yugma, pairing, a bond so fundamental that disturbing one instantly affects the other, like plucking a string on one side of the universe and hearing its echo on the other. What's astonishing is how these hymns avoid rigid definitions, opting instead for fluid metaphors that accommodate multiple layers of truth. The Rig Veda speaks of particles singing together though far-flung, a description that could easily describe electrons in a superconductor maintaining coherence across space. Compare this to today's technical jargon terms like wave function collapse or Bell's inequality, and you realize the rishis were pointing to the same phenomena, but through the language of poetry rather than mathematics. Consider the Nasadiya Sukta's closing lines. The gods came afterwards with the creation of this universe. This isn't mythology, it's a radical assertion that observers, the gods, emerge from the system they measure, a notion quantum physics echoes with its observer effect. The hymn's ambiguity, maybe even the creator doesn't know, parallels Heisenberg's uncertainty principle, acknowledging the limits of human comprehension when faced with reality's fluid nature. The brilliance of these texts lies in their refusal to separate the spiritual from the physical. When the Rig Veda says all is woven like a fabric, it's not just a metaphor for cosmic unity, it's a functional description of quantum field theory. The threads are the invisible forces binding particles. The weave is spacetime itself. Modern physics confirms this. Particles aren't isolated marbles but excitations in a shared field, vibrating in unison like the Vedas, dancing flames of the same fire. Yet the contrast in language reveals something profound. Where science seeks to pin down reality with equations, the Vedas embrace paradox. They describe light as both wave and particle millennia before quantum duality was formulated, yet they do so through layered imagery, light as a swan gliding on water, simultaneously touching the surface and soaring above it. This isn't vagueness, it's precision of a different kind, using poetry to capture truths that rigid terminology might obscure. Perhaps most striking is how these ancient seers anticipated entanglement's most puzzling aspect, non-locality. The Rig Veda's hymns repeatedly emphasize actions that occur here and there simultaneously, like drums beating in unison across mountains. Today, we'd call this quantum synchronization, where particles share states without any detectable signal passing between them. The texts even hint at decoherence, the idea that observation disrupts the system, with verses about the seer whose gaze scatters the deer, a metaphor for measurement collapsing quantum superposition. By weaving together metaphor and metaphysics, the Rig Veda achieves what modern science often struggles with, conveying the experience of quantum reality, not just its mechanics. When it says, "The wise see the same in all directions," it's not describing a lab result. It's inviting us to perceive entanglement not as a quirk of physics, but as the very fabric of existence. And that might be the most revolutionary insight of all. The Bhagavata Purana doesn't just describe a universe, it paints a multiverse, an intricate web of realities where time, space, and consciousness intertwine in ways that defy ordinary logic. Consider its account of Vishnu's divine abode, Vaikuntha, where past, present, and future exist simultaneously. The text describes messengers traveling instantaneously between realms, delivering information across cosmic distances without delay. Replace messengers with quantum particles, and you've got a narrative that mirrors quantum entanglement, a phenomenon where information passes between linked particles faster than light, as if space and time were mere illusions. What's even more astounding is how the Purana frames these realms as vibrational realities. Each loka, or plane of existence, resonates at a distinct frequency, much like how quantum fields vibrate to produce different particles. The text describes higher lokas as subtler and more luminous, hinting at energy states modern physics might call higher dimensional or low entropy. When the Bhagavata speaks of beings pervading all worlds while seated in one place, it echoes the quantum concept of non-locality, where a particle's influence isn't confined to a single location. Imagine folding a piece of paper so two distant points touch. The Purana's cosmology suggests the universe operates similarly, with seemingly separate realms intimately connected beneath the surface. Then there's the matter of parallel universes. The Purana describes countless Brahmandas or cosmic eggs, each with its own laws and timelines. Some are born from Vishnu's pores, others collapse and re-emerge like bubbles in a vast ocean. This isn't just mythology, it's a striking analog to the multiverse theory, where physicists propose our universe is one of many in an infinite quantum foam. The text even anticipates the idea of bubble universes, regions where physical constants might differ, stating, "As one sun lights many worlds, so one creator sustains innumerable Brahmandas." Modern science speculates that other universes could have weaker gravity or altered particle masses, echoing the Purana's vision of realms where time flows like honey or fire chills like moonbeams. Visualizing these ideas side by side reveals uncanny parallels. Animations of Puranic cosmology often show concentric spheres of existence, nested like layers of an onion, a structure not unlike diagrams of quantum field interactions where energy densities vary across scales. The text's descriptions of netherworlds where perception inverts could be read as metaphors for antimatter or negative energy states, and when it speaks of divine beings seeing all time as a single glance, it resonates with quantum gravity's notion that time might emerge from a timeless substrate, just as a movie projects motion from static frames. But here's where the Purana surpasses even modern speculation. It doesn't just describe multiple universes, it suggests they're conscious. The text asserts that each Brahmanda pulses with its own awareness, a claim that aligns with panpsychist interpretations of quantum mechanics, where consciousness might be fundamental to reality. When quantum physicists wrestle with the observer effect, how measurement collapses probability into certainty, the Purana offers a bold answer. The observer isn't separate from the system. Every universe, every particle is alive with the same divine presence. As threads woven into cloth are still thread. This isn't passive philosophy. The Bhagavata insists these truths can be directly perceived through yogic practice, much as scientists probe reality through experiments. Its descriptions of sages crossing dimensions in meditation, parallel quantum tunneling, where particles bypass barriers instantaneously. The text's most radical claim, that the cosmos is a play, leela of consciousness, a dynamic, self-organizing system where separation is the illusion and entanglement the deeper truth. Sound familiar? It's the same conclusion quantum physicists reach when they admit, the universe doesn't just contain connections, it is connection. The Yoga Vasishta, a sprawling spiritual text attributed to the sage Valmiki, doesn't just describe the universe, it shatters our conventional understanding of it. Imagine holding a single dewdrop and seeing within it the reflection of the entire sky. This isn't just poetry. The text asserts that every fragment of existence, from a grain of sand to a human thought, contains the entirety of creation. Sound impossible? Quantum holography, a cutting-edge theory in physics, suggests something startlingly similar. Just as a hologram encodes a whole image in each of its parts, some physicists propose that information about the entire universe might be embedded in every tiny region of space. The Yoga Vasishta calls this SRRV a letter 1 E4 3 KHLVID a letter 1 E4 3 Brahma. All this is Brahman, while quantum theorists use terms like holonomic universe, but the message is the same. Separateness is an illusion, and the cosmic blueprint repeats infinitely at every scale. Take the text's vivid allegory of the dreamer and the dreamed. A king named Lavana experiences an entire lifetime falling in love, ruling a kingdom, even dying only to awaken under a tree, realizing mere moments had passed. The Yoga Vasishta uses this to illustrate a radical proposition. What we call waking life might be no more fundamentally real than Lavana's dream, just a more stable state of consciousness. Here's where quantum decoherence comes in. Modern physics shows that particles exist in multiple states simultaneously, superposition, until interaction with their environment collapses them into definiteness. The Yoga Vasishta's dream analogy mirrors this. Lavana's dream decoheres when he wakes, much like a quantum system losing its superposition when observed. Both traditions suggest reality isn't fixed, it's a dynamic interplay of potentialities that solidify through interaction. But the text goes further, proposing something even bolder, that advanced yogis can manipulate this decoherence through focused awareness. It describes sages who step between worlds as one steps through doors, consciously collapsing quantum possibilities into tangible experience. Modern experiments hint at similar possibilities. In the quantum Zeno effect, frequent observation of a system can effectively freeze its evolution like a watched pot that never boils. The Yoga Vasishta implies that sustained meditative focus might function similarly, stabilizing certain realities while allowing others to dissolve. Imagine a laboratory where consciousness itself is the instrument, not just observing particles but actively shaping their behavior through attention. The text's assertion that the mind woven in space-time becomes space-time finds eerie resonance in theories like participatory universe models, where observation doesn't just measure reality but co-creates it. One of the most daring passages describes a sage materializing objects by seeing them into being, an idea that sounds like fantasy until you consider quantum teleportation experiments, where information about a particle's state is instantaneously transferred across distances. The Yoga Vasishta frames this as the natural outcome of realizing reality's holographic nature, when every part contains the whole, influencing one point reverberates everywhere. Modern physics struggles to explain non-local effects like entanglement, but this ancient text offers a startlingly simple explanation. Separation was never real to begin with. What if we could test these ideas today? The text gives clues. It describes advanced meditators entering Turiyatita, a state beyond waking, dreaming, or deep sleep, analogous to quantum coherence where systems operate without decohering. Neuroscience studies on expert meditators show brainwaves synchronizing in ways that defy classical models, suggesting a biological basis for these claims. The Yoga Vasishta even outlines a practice called antadarshana, inner witnessing, where one observes thoughts without attachment, a method that parallels quantum measurement techniques designed to minimize observer interference. The implications are staggering. If consciousness can collapse reality's probabilities like a quantum observer, then disciplines like focused intention or lucid dreaming aren't just spiritual exercises. They're potential interfaces with existence's fundamental code. The text warns that most people remain like stones in the river of time, unaware they're swimming in a hologram. But for those who dare to look deeper, the Yoga Vasishta offers more than philosophy. It's an invitation to experiment with the very fabric of being. If you've ever plucked a guitar string and watched it ripple into motion, you've witnessed a tiny echo of the universe's deepest secret vibration as the foundation of reality. Kashmir Shaivism, an ancient school of Hindu thought, calls this Spanda the divine throb of consciousness that brings form into being. The Spanda Karikas, sacred texts of this tradition, describe reality not as static objects but as pulsating waves of energy, where even the densest matter is just consciousness vibrating at a slower frequency. Now hold that thought and leap into a modern physics lab. What's the core principle of quantum mechanics? That particles exist as both waves and discrete points, their behavior dictated by vibrational frequencies. The parallels aren't just striking, they're downright uncanny. Tantric masters didn't need particle accelerators to grasp this. They spoke of nada, the cosmic sound humming through creation, as the source of all form. The Vajnana Bhairava Tantra, a key Kashmir Shaivism text, instructs meditators to focus on the unstruck sound, anahata nada, a vibration beyond physical hearing that structures reality. Fast forward to string theory, and you'll hear physicists describing nearly the same thing. Infinitesimal strings vibrating at different frequencies to produce quarks, electrons, even gravity. The math is complex, but the essence is simple. Just as a violin's strings create distinct notes, the universe's fundamental strings generate particles through resonance. What's mesmerizing is how these traditions describe vibration's creative power. Kashmir Shaivism uses the metaphor of a spider's web. Gentle tremors at the center ripple outward, manifesting patterns without breaking the whole. Quantum field theory mirrors this. Disturbances in the quantum vacuum propagate as particles, like waves forming on a pond when you toss a stone. The Shiva Sutras declare, the universe is the expansion of Spanda, suggesting existence unfolds from a single rhythmic pulse. Compare that to the Big Bang's aftermath, where quantum fluctuations seeded galaxies, an explosion of vibrational potential frozen into form. But here's where Spanda theory gets even more provocative. Tantric texts assert that attention itself alters vibration. Advanced practitioners claim to shift matter's density by shifting their awareness, a notion that sounds mystical until you consider quantum observation's power. In the double-slit experiment, particles behave as waves until measured, then choose a definite state. The Pratyabhanyodayam, a Kashmir Shaivism manual, puts it bluntly: consciousness contracts or expands according to its own will. Whether through meditation or microscopy, the implication is the same. Vibration isn't just how reality works, it's how we participate in its unfolding. This isn't metaphor. Neuroscience now confirms focused intention changes brainwave frequencies, which in turn affect the body's molecular vibrations. Ancient yogis spoke of chakras as spinning vortices of energy, each resonating at specific harmonics, a concept that aligns eerily with biophoton research, where cells communicate through light waves. When the Netra Tantra says, "By sound forms arise, by sound they dissolve," it's offering more than poetry. It's a functional roadmap of creation where frequency bridges mind and matter. The most profound takeaway: Spanda dissolves the line between observer and observed. Quantum physics struggles with this. At base level, particles respond to consciousness in ways that defy classical physics. Tantra embraces it. The vibratory nature of reality means you are the vibration. Your thoughts, your breath, even your silence ripple through the quantum web. As the Vijnana Bhairava teaches, in the gap between two breaths the universe is born. That's not mysticism, it's a challenge to see every moment, every atom, as a collaboration between your awareness and the cosmic hum. The Upanishads introduce us to Jiva, the individual soul, a spark of consciousness that experiences reality through the lens of separateness, yet remains eternally tethered to the universal Brahman. But what if this ancient concept holds the key to one of quantum physics' most perplexing mysteries, the role of the observer? Modern experiments repeatedly show that particles exist in a haze of probabilities until measured, as if the very act of looking forces reality to choose a state. The Upanishads might have given us a framework for this phenomenon centuries ago. They describe Jiva not just as a passive witness, but as an active participant in creation, with its attention shaping the world it perceives. The Chandogya Upanishad declares, "You are what your deep desire is. As your desire is, so is your will. As your will is, so is your deed." Replace desire with observation, and you've got a startling precursor to the quantum observer effect, where consciousness collapses possibility into actuality. Consider the Mahabharata's riveting tale of sage Vishwamitra, who through sheer willpower creates an entire parallel universe, a svarga, to challenge the gods. He doesn't pray for it, he intends it into being, as if his focused awareness manipulated the quantum field itself. Fast forward to 21st century labs, where quantum biologists are discovering how enzymes might exploit superposition to choose optimal chemical pathways, almost as if matter responds to a kind of molecular intention. Or take the double-slit experiment's baffling results. When unobserved, particles behave as waves. The moment a detector is introduced, they decide to act like particles. The sage's disciplined focus and the lab's detector might be tapping into the same principle, that reality remains fluid until consciousness interacts with it. This raises a daring question. Were ancient rishis practicing what we might now call quantum meditation? The Yoga Sutras describe samadhi, a state where the meditator's consciousness merges with the object of contemplation, erasing the boundary between observer and observed. In quantum terms, this resembles entanglement, a perfect correlation where two systems become inseparable. The Taittiriya Upanishad even hints at non-local awareness, describing Jiva as smaller than an atom, yet vaster than the sky. Modern experiments show entangled particles mirroring each other instantly across galaxies, defying classical notions of distance. Could yogic adepts, through dhyana meditation, have been entangling their awareness with the fabric of reality itself? The implications are staggering. If Jiva truly functions as a quantum observer, then disciplines like mantra repetition or visualization aren't just spiritual exercises, they're technologies for collapsing reality's probabilities. The Brihadaranyaka Upanishad describes creation as a projection of the self, stating, "In the beginning, this was but the self alone, it thought, let me multiply." Compare that to physicist John Wheeler's participatory universe hypothesis, where observers collectively bring the cosmos into definite existence. Both suggest a cosmos that doesn't merely include consciousness, it arises from it. Yet here's the paradox the rishis grasped early. Jiva is both the architect of illusion and the key to liberation. Just as quantum systems decohere when observed, the Upanishads teach that ordinary perception fragments wholeness into duality. But they also offer an escape through jnana knowledge or bhakti devotion. The jiva can realize its true nature as Brahman, collapsing the illusion of separation. In a breathtaking parallel, some quantum interpretations propose that universal consciousness might be the only real observer, with individual observers merely facets of its measurement. The Kena Upanishad whispers this truth, that which cannot be seen by the eye, but by which the eye sees, know that alone as Brahman. Perhaps this ancient dialogue between Jiva and Brahman mirrors the quantum dance between observer and observed, not as separate entities, but as two notes in the same cosmic chord. Whether through meditation or microscopy, the lesson is the same. To perceive reality isn't just to witness it, it's to shape it. Imagine stepping into a celestial court for what feels like mere hours, only to return home and find centuries have passed. The Mahabharata's King Kakadmi lived this exact paradox, a story that reads like ancient science fiction. After ascending to the heavens for divine counsel, he discovers his brief absence spanned generations on earth. His kingdom is gone, his lineage scattered. At first glance, this seems like mythic exaggeration until you recall Einstein's revelation: time isn't absolute. It bends. The faster you move, the slower time ticks for you relative to others. This is relativistic time dilation, proven by atomic clocks on jets ticking slower than their grounded counterparts. The Mahabharata's celestial realm, where Kakadmi lingered, might just be describing a region of extreme gravitational fields or velocities, warping time as profoundly as a black hole's event horizon. Visualize the scene from Interstellar, where hours on Miller's planet equal years for those orbiting afar. The waterlogged world's crushing gravity stretches time like taffy, a perfect cinematic parallel to Kakadmi's experience. Hindu cosmology goes further, framing time itself as cyclical and elastic. The yugas Satya, Treta, Dwapara, Kali aren't just epochs but repeating phases where time's flow allegedly changes speed. The ancients claimed moral decline in Kali Yuga makes perception of time feel faster, almost as if subjective experience syncs with cosmic rhythms. Modern physics offers a startling counterpart. Near a massive object like a neutron star, clocks tick demonstrably slower. Could the yugas encode an intuitive grasp of spacetime's curvature? Consider the Bhagavata Purana's claim that Brahma's day equals 4.32 billion human years, a timescale aligning eerily with Earth's geological cycles. Or the Vishnu Purana's description of higher realms where one breath lasts 1,000 human years. These aren't random numbers, they mirror how general relativity predicts time dilation escalates exponentially near extreme energy densities. When the Mahabharata describes Arjuna's celestial training compressing decades of mastery into days, it evokes the twin paradox, an astronaut sibling aging slower than their Earth-bound twin. The real genius lies in how these texts intertwine time's fluidity with consciousness. Kakadmi's shock upon returning mirrors the disorientation of theoretical astronauts returning from near-light-speed journeys. But the Mahabharata adds a layer modern science seldom addresses: the psychological toll of time slippage. Kakadmi doesn't just recalibrate calendars, he grieves. His story suggests ancient seers understood time dilation not just as a physical phenomenon but an existential trial, one that bends identity as surely as space-time. Perhaps most provocative is the parallel between Vedic time cycles and multiverse theories. The Puranas speak of innumerable universes, each with its own rhythm of time, some where a blink lasts an eon, others where civilizations rise and fall in a heartbeat. This mirrors quantum cosmologies, bubble universes, where inflationary regions might experience time at radically different rates. When the Mahabharata states, "Time cooks all beings," it's less metaphor than physics. Time isn't a backdrop but an active ingredient in reality's recipe. So were the rishis merely spinning poetic allegories, or did their meditative states grant them a vantage point where time's illusions fell away? Modern neurology shows deep meditation can alter time perception, stretching moments into subjectively eternal nows. Combine that with relativistic physics and Kakodme's journey starts looking less like fantasy and more like an experiential truth, a reminder that the distinction between myth and science might just be a matter of temporal perspective. At the heart of quantum mechanics lies a riddle so perplexing it's been debated for nearly a century: the measurement problem. When no one's looking, particles exist in a ghostly superposition of all possible states. The moment you observe them, they snap into a single, definite reality. It's as if the universe hesitates until consciousness makes a choice. Now, transport this idea back over 1,000 years to the debates of Adi Shankara, the towering Vedantic sage who proposed a strikingly similar concept, Drishthi-Srishti, the doctrine that creation unfolds through perception. His famous analogy, a coiled rope mistaken for a snake in dim light. Just as quantum systems remain undefined until measured, Shankara taught that the world's solidity is an illusion, a projection crystallized by the act of seeing itself. The parallels are too precise to ignore. In the double-slit experiment, electrons behave as waves when unobserved, spreading out in a haze of possibilities. But the instant a detector clicks, they choose a single path, as if embarrassed to be caught in ambiguity. Shankara's rope-snake metaphor mirrors this. The rope Brahman, ultimate reality, is misperceived as a snake, the tangible world, only when the observer's mind imposes form onto formlessness. Both frameworks suggest the same radical idea: reality isn't an independent stage. It's a dance between consciousness and potential. Modern physics grapples with the collapse of the wave function, the moment probability condenses into actuality. But who or what triggers this collapse? Interpretations vary wildly. The Copenhagen school insists it's the observer's intervention. The many worlds theory claims every possibility branches into parallel universes. Vedanta, meanwhile, cuts through the debate with ruthless simplicity. There is no collapse, only misperception. The snake was always rope. The particle's blurry superposition was always Brahman's unbroken wholeness. The Vivekachudamani, a key Advaita text, declares, "The world is unreal, only Brahman is real, not as denial, but as a reminder that what we call real is just the light of awareness refracting through the prism of mind." Lab experiments keep deepening the mystery. Quantum delayed choice experiments show particles can retroactively decide their past behavior based on future measurements, a twist that echoes Shankara's teaching that time itself is part of the illusion. The quantum eraser experiment demonstrates that erasing information about a particle's path can restore its wave-like behavior, as if reality edits itself based on what the observer knows. Compare this to the Yoga Vasistha's assertion: the world appears as the mind imagines it. Both reveal a cosmos that's less a fixed object and more an interactive story, shaped by the questions we ask. Yet there's a crucial divergence. Physics wrestles with the how of observation's power, whether it's the detector's machinery or human consciousness that matters. Vedanta sidesteps the debate by collapsing observer and observed into one. The MA macron letter 1 E4 7 letter 1 E0 DU macron KY a Upanishad states, the knower and the known are non-different. In this view, the measurement problem vanishes because there's no separate you to measure it. There's only Brahman masquerading as both scientist and electron, playing hide and seek with itself. Perhaps the most haunting implication is that both traditions across millennia and methodologies converge on the same unsettling truth. Whether through meditative insight or mathematical rigor, they point to a universe that doesn't just respond to observation but is constituted by it. The Panchadasi likens creation to a dreamer's world, coherent only until waking. Quantum physics, with its particles that blur into waves, whispers the same warning. What we call reality might just be the most persistent illusion of all. Mirabai's ecstatic verses to Krishna pulse with a truth that defies logic. Her beloved is both impossibly distant and intimately close, separated by miles yet present in every breath. When she sings, "My dark one dwells beyond all horizons, yet dances in my chest like a flame," she's not just expressing devotion, she's describing quantum non-locality in the language of the heart. Modern physics reveals that entangled particles communicate instantaneously across vast distances, as if space were an illusion. Bhakti poets like Mirabai, Kabir, and Tukaram articulated this same paradox centuries earlier. Divine connection transcends physical separation because at the deepest level, separation doesn't exist. Listen to the way Tukaram describes his encounters with Vitthal. "You stood on the riverbank, yet your laughter filled my bones before my eyes could see you." Replace Vitthal with entangled photon, and you've got a near-perfect metaphor for quantum teleportation, where information passes between particles faster than light, bypassing conventional space-time. The parallels aren't accidental. These poets weren't merely crafting beautiful imagery, they were documenting an experiential truth. Through intense bhakti devotion, they dissolved the illusion of distance, merging with the divine in a way that mirrors quantum coherence, where two systems become one despite apparent separation. Now consider the experiments. In labs from Vienna to Shanghai, scientists teleport quantum states between particles kilometers apart, achieving what Einstein called spooky action. Play a clip of Mirabai's Payoji main Ram Ratan Dihan Payo. I found the treasure of Ram's name over footage of these experiments, and the synergy is undeniable. Both traditions, bhakti and quantum physics, point to a reality where connection isn't bound by proximity. When Kabir writes, "The river and its waves are one, who can say where the water ends and the wave begins?" He's anticipating physicist David Bohm's holographic universe, where every part contains the whole. The real magic lies in how bhakti resolves non-locality's emotional paradox. Physics can describe how particles remain linked, but it struggles with the experience of such connection. Bhakti poetry fills that gap. When Andal, the Tamil saint, clothes herself in garlands meant for her absent Krishna and declares, "These flowers carry his touch," she's demonstrating entanglement's human dimension, love as a force that collapses distance. Modern studies on non-local consciousness, like twins feeling each other's pain across continents, hint that devotion's claims might be more than metaphor. This isn't just about parallels, it's about practice. Bhakti isn't passive belief, it's an active entanglement, a deliberate collapsing of the ego's illusion of separation. When a devotee chants a deity's name with such intensity that the boundaries between self and God blur, they're recreating in consciousness what physicists achieve with lasers and detectors. The Narada Bhakti Sutra states, "As iron ignites when touched by fire, the devotee becomes one with the divine." Quantum entanglement shows iron and fire don't even need to touch, their states synchronize beyond physical contact. So next time you hear a Bhajan's refrain or read a particle physics paper, listen for the shared refrain. Separation is the illusion, and connection, whether through love or quantum fields, is the deeper truth. The poets and physicists are singing the same song, just in different keys. Long before Democritus pondered the nature of matter, an ancient Indian sage named Kanada was crafting a theory of atoms so precise it still resonates with modern quantum physics. The Vaisheshika school, founded around 600 BCE, didn't just suggest the existence of fundamental particles, it mapped their behaviors with startling accuracy. Kanada called these indivisible units paramonyu, describing them as eternal, indestructible, and beyond sensory perception unless combined. Sound familiar? Swap paramonyu for quarks or leptons, and you've got a blueprint eerily similar to today's standard model of particle physics. What sets Vaisheshika apart is its intricate classification system. Kanada proposed that Paramanas could combine in dyads or triads, never singly forming molecules he called dwinuka and trinuka. These groupings mirror how quantum particles bond through valence shells, with electrons pairing up or forming triple bonds in chemistry. The texts even describe Paramanas as having an innate vibratory quality, a precursor to the quantum mechanical concept of wave-particle duality. Picture this: animations of Sanskrit sutras from the Vaisheshika sutras overlaying 3D molecular models, showing how the atom of earth possesses smell, the atom of water taste, aligns with modern understanding of how atomic arrangements create sensory properties. The parallels aren't superficial, they're structural. But here's where Kanada's insights become truly prophetic. He claimed Paramanas could neither be created nor destroyed, only transformed, an uncanny anticipation of the law of conservation of mass energy. The texts detail how heat causes atoms to vibrate faster, changing states from solid to liquid to gas, foreshadowing kinetic molecular theory by millennia. Even more striking is the idea that different elemental paramanas, earth, water, fire, air, combine in specific ratios, a concept that predates Dalton's atomic theory by over 2,000 years. When the Vaisheshika Sutras state, as the spider emits and retracts its web, matter emerges from atoms without external force, it's hard not to think of quantum field fluctuations generating particles spontaneously from the vacuum. The real genius lies in Kanada's grasp of relational properties. Unlike Greek atomists who saw atoms as passive and mechanical, Vaisheshika describes paramanas as dynamic entities whose behaviors depend on context, much like quantum particles whose spin or position is defined only in relation to measurement. The texts even hint at non-locality, suggesting atoms separated by space retain invisible connections, as two birds on one tree share a single breath. Modern experiments with entangled electrons or photons reveal this same counterintuitive linkage, where particles instantaneously respond to each other's states across vast distances. Perhaps most revolutionary is how Kanada bridged the physical and metaphysical. While Democritus saw atoms moving through void, Vaisheshika posits Akasha, the subtlest medium akin to the quantum field, as the canvas for atomic interactions. The sutras describe paramanas as neither heavy nor light, defying classical notions of gravity centuries before Newton. This aligns with quantum weirdness, where particles in superposition lack definite properties until observed. When the texts declare, the atom is the bridge between the seen and unseen, they're articulating what physicists now grapple with, that the quantum realm operates by rules beyond everyday intuition. Visualizing these ideas makes the connections undeniable. Imagine split-screen animations. On one side, ancient Indian scholars drawing dwinuka formations in sand. On the other, CGI of hydrogen atoms bonding into H2 molecules. The Vaisheshika Sutras even classify atomic motion into linear, curvilinear, and vibrational categories, matching translational, rotational, and vibrational modes in quantum chemistry. It's as if Kanada glimpsed molecular spectroscopy through sheer contemplation, describing how fire atoms in motion produce color, long before we understood photons emitting specific wavelengths. The implications are profound. This wasn't speculative philosophy, it was a systematic science of the infinitesimal, complete with causation laws and epistemology. Kanada's assertion that knowledge of the atom liberates finds echoes in Feynman's famous quip that quantum mechanics underpins everything. Both traditions, separated by epochs, converge on a startling truth: to comprehend the atom is to touch the fabric of reality itself. Whether through Vedic meditation or particle accelerators, the quest remains the same: to unravel the mysteries woven into the very heart of matter. The Bhagavad Gita's battlefield isn't just a clash of armies, it's a collision of two profound visions of karma. On one side, Arjuna trembles at the weight of destiny, convinced his actions are scripted by cosmic law. Krishna, meanwhile, urges him to act with freedom, declaring, "You have the right to your labor, but not to its fruits." This ancient tension between fate and free will mirrors quantum physics' most persistent paradox: the dance between probability and certainty. Karma, often misunderstood as rigid cosmic accounting, might be something far more fluid, an entangled web of potentialities where every choice ripples through the quantum field, collapsing certain futures into reality while leaving others as ghostly possibilities. Think of Schrödinger's cat, that iconic thought experiment where a feline in a box exists in a superposition of alive and dead until someone peers inside. Now imagine karma operates similarly. Your actions aren't predetermined sentences etched in some celestial ledger. Their probability waves countless branching paths where generosity might amplify opportunities in one timeline while selfishness narrows them in another. The Gita hints at this when Krishna describes how the unsettled mind creates its own reality, echoing quantum observation's power to shape outcomes. Just as the cat's fate hangs in limbo until observed, your karmic results might remain probabilistic until consciousness interacts with them. This redefines traditional karma's cause and effect chains. Classical interpretations paint karma as Newtonian: every action has an equal, predictable reaction. But quantum karma, it's more like a cosmic game of plinko, where your choices set probabilities in motion, but randomness and entanglement add wild cards. The Jaimini Sutras, ancient texts on karma, even describe dormant karmas that activate under specific conditions, like quantum states remaining latent until measured. When Arjuna frets over the ethics of battle, Krishna doesn't offer a fixed karmic outcome. He reveals a spectrum of possibilities contingent on Arjuna's choices and awareness. The Gita's debate gains new dimensions through quantum lenses. Deterministic karma assumes every sorrow or joy is payback for past deeds. Quantum karma, however, accommodates uncertainty. Your past actions bias probabilities but don't lock you into a single fate. It's the difference between rolling a loaded die weighted by past choices and a predetermined outcome. Modern physics shows particles can remember past interactions through decoherence, yet still defy predictions. Similarly, karma might imprint tendencies without erasing free will's spark. When Krishna says, "Raise yourself by yourself," he's hinting at agency within karmic probability fields. Now for the cat analogy, picture two boxes. One holds Schrödinger's feline, the other your karmic potential. Open the first box and the cat state collapses. Open the second through mindful action and a karmic possibility crystallizes, not because destiny decreed it, but because your awareness participated in its manifestation. The Brihadaranyaka Upanishad whispers this truth: as is your desire, so is your will. As is your will, so is your deed. Desire here isn't whim, it's the focused intention that nudges quantum probabilities, like photons choosing particle or wave behavior based on experimental setup. The implications are liberating. If karma were purely deterministic, spiritual growth would be algorithmic: input good deeds, output blessings. Quantum karma, though, mirrors evolutionary biology's punctuated equilibrium, long periods of karmic accumulation punctuated by leaps when consciousness shifts. The Gita's battlefield is that pivot point. Arjuna's despair creates fertile uncertainty, a superposition of futures. Krishna's guidance doesn't predict outcomes. It helps Arjuna collapse the wave function toward clarity. So was karma quantum all along. The texts leave clues. Tantric traditions describe karmic seeds, karma bija, lying dormant until conditions ripen, akin to quantum tunneling, where particles suddenly overcome barriers when probabilities align. Buddhist Abhidharma even quantifies karma's weight, suggesting some actions create heavier probability distortions. This isn't mysticism, it's a framework for how consciousness navigates a probabilistic universe. The takeaway: you're neither puppet nor pure chance. You're a quantum actor in a karmic field where every thought and action weights the dice, but the role remains yours to make. As the Gita concludes, the wise see chance and choice as two sides of one coin. Heads, you shape your future. Tails, the universe surprises you. Either way, the game's alive with possibility. Ayurveda speaks of prana, that elusive life force threading through every cell, every breath, every heartbeat. But what if this ancient concept isn't just poetic imagery, but a startlingly accurate map of quantum coherence in living systems? Modern science reveals something astonishing. Photosynthesis, the very engine of life, depends on quantum effects. Plants don't just absorb sunlight, they orchestrate its energy through a delicate quantum dance, where photons explore multiple paths simultaneously to find the most efficient route. Now hold that thought and turn to the Charaka Samhita, where prana is described as the subtle vibratory intelligence guiding nourishment to its destination. The parallels are uncanny. Both traditions, separated by millennia, point to a hidden layer of reality where energy and information flow not through brute mechanics, but through something far more mysterious: coherence. Take turmeric, that golden staple of Ayurvedic medicine. For centuries, texts like the Sushruta Samhita detailed its use with black pepper to enhance bioavailability, a synergy modern science now confirms. Piperine in pepper boosts curcumin absorption by 2000%. But here's where it gets quantum. Recent studies show curcumin's healing properties may stem from its ability to interact with cellular membranes at the subatomic level, altering electron distributions in ways that reduce inflammation. Labs using quantum sensors have detected resonant energy transfers between turmeric compounds and human proteins, almost as if they're tuning to the same vibrational frequency. This isn't just chemistry, it's quantum biology in action, mirroring Ayurveda's claim that herbs work through pranic signatures resonating with bodily tissues. The implications are staggering. Ayurveda classifies herbs not just by chemical compounds, but by their vibratory qualities: light, sharp, or heavy. These descriptors eerily align with how quantum systems behave. Light herbs might interact with high-frequency cellular processes, while heavy ones stabilize low-frequency structures. The Ashtanga Hridaya describes diseases as discordant rhythms in the body's energy field, a concept that quantum biology echoes when it examines how disrupted electron spin states contribute to oxidative stress. Imagine applying quantum sensors to test Ayurvedic formulations like Triphala. Could we measure its famed Rasayana effect as a harmonization of cellular quantum states? Now consider Panchakarma, Ayurveda's deep detox protocol. Texts describe it as recalibrating pranic flow, but quantum biology offers a fresh lens. Could therapies like medicated oils and steam baths be optimizing the body's quantum coherence? Studies on thermal therapies show heat can enhance quantum tunneling in enzymes, boosting metabolic efficiency. Meanwhile, Ayurvedic pulse diagnosis, long dismissed as subjective, might find validation in quantum touch research, where practitioners detect subtle electromagnetic fluctuations at the atomic level. The real breakthrough would be testing these ancient protocols with quantum technologies. Imagine embedding nanodiamonds with nitrogen vacancies, ultrasensitive quantum sensors, into herbal preparations to track their real-time interaction with cells. Or using terahertz spectroscopy to map the pranic pathways of energy meridians described in Ayurvedic texts. Early experiments at institutions like the University of California already show how chlorophyll's quantum coherence maximizes energy transfer. Could tulsi leaves or ashwagandha roots operate similarly? This isn't about reducing Ayurveda to biochemistry. It's about expanding science to accommodate a deeper truth the rishis grasped intuitively. Life isn't just molecular, it's vibrational. When the Vedas declare prana is the web that holds all atoms in place, they're hinting at a quantum fabric where consciousness, energy, and matter intertwine. Modern labs are just beginning to catch up, discovering that DNA emits biophotons. Neurons might use quantum entanglement for memory, and mitochondria function as biological superconductors. The invitation is clear. Instead of dismissing Ayurveda as folklore, what if we let it guide the next frontier of quantum medicine? Those handwritten palm leaf manuscripts might contain the blueprints for a revolution, one where healing isn't about forcing chemicals into place, but about restoring the universe's hidden symphony in every cell. Vishnu reclines on the cosmic serpent Ananta, floating not in water, but in a shimmering sea of quantum foam. This iconic image from the Puranas takes on new meaning when you realize modern physics describes a similar scene, an infinite froth of bubble universes, each a Brahmanda or cosmic egg, emerging and dissolving within an eternal ocean of potential. The Matsya Purana doesn't just hint at this, it paints it in vivid detail. As countless bubbles arise on the waters of the infinite, so too do universes manifest from the body of the divine. Replace bubbles with quantum fluctuations, and suddenly, an ancient creation myth becomes a startlingly precise metaphor for multiverse theory. What's astonishing is how these texts describe the life cycle of these cosmic eggs. The Vishnu Purana speaks of universes breathing, expanding during Vishnu's exhalation and contracting during inhalation, a rhythm mirroring the Big Bang and Big Crunch hypotheses. But here's where it gets quantum. Modern cosmology suggests our universe might be one bubble in a vast, false vacuum, where quantum tunneling could spawn new universes with entirely different physical laws. The Bhagavata Purana anticipates this, describing Brahmandas within Brahmandas, each with unique properties, some where light moves slower, others where gravity repels. These aren't random fantasies, they're fractal-like layers of reality that align with physicists' landscape of possible universes in string theory. Visualizing these parallels makes them undeniable. Imagine CGI of Vishnu's cosmic form, his every pore emitting spiraling galaxies then dissolve into a simulation of quantum foam, where space-time itself froths with evanescent universes. The Karma Purana's description of creation as a cascade of golden sparks from the primordial fire could easily depict quantum field fluctuations generating virtual particles. Even the scale matches. Quantum foam's bubbles are theorized to be a trillion times smaller than an atom, while the Puranic Anu atom is said to contain entire worlds, a poetic nod to scale invariance where patterns repeat infinitely at every level. But the real genius lies in how these texts handle entropy. The Shiva Purana describes cosmic dissolution not as destruction, but as transformation, energy returning to its unmanifest state, akin to quantum fields settling back to their ground state. Modern physics struggles with entropy's arrow, but the Puranas propose a cyclical solution. Every ending seeds a new beginning, just as quantum foam's bubbles nucleate endlessly. When the Matsya Purana states, "That which is scattered shall gather, that which is gathered shall scatter," it's not just philosophy, it's a prescient take on the universe's fundamental dynamism. Perhaps most striking is the emotional resonance. Science presents bubble universes as cold mathematical probabilities, but the Puranas infuse them with purpose, each Brahmanda a Leela, divine play of consciousness. Quantum physics might describe how universes form, the rishis suggest why. Their answer, that existence itself is an experiment in infinite possibilities, a thought that makes our search for meaning not just valid but vital. Close your eyes for a moment and picture the surface of a stormy lake, waves crashing, water churning in chaotic patterns. Now imagine those waves gradually settling into perfect stillness, reflecting the sky with crystalline clarity. This isn't just a meditation metaphor, it's a stunning parallel to what happens at the quantum level when consciousness interacts with reality. Yogic texts like Patanjali's Yoga Sutras describe meditation as the art of chitta vritti nirodha, silencing the fluctuations of the mind. What if this ancient practice isn't just about inner peace, but a literal tuning of quantum noise into coherent states? Modern experiments suggest something extraordinary. Trained meditators can influence random number generators, devices that rely on quantum uncertainty, simply by focusing their awareness. It's as if their stabilized consciousness acts like a laser beam, collapsing probabilities into measurable order. Think about the double-slit experiment's bizarre results, how particles behave as waves until observed, then snap into definiteness. Patanjali's teachings on dharana, concentration, and dhyana, absorption, outline a methodical process for refining attention to such a degree that the observer's very presence begins to structure reality. Studies at the Princeton Engineering Anomalies Research Lab recorded meditators causing statistically significant deviations in random event generators, machines designed to output pure chance. Their brainwaves, measured in deep meditation, showed patterns resembling the coherence seen in superconductors, where electrons move in perfect unison. The Yoga Sutras might as well be a quantum lab manual, with its step-by-step instructions for achieving samadhi, that state where subject and object merge into seamless unity, the human equivalent of quantum entanglement. Here's where it gets even more fascinating: quantum decoherence, the process where a system loses its wave-like properties and chooses a state, usually happens through environmental interaction. But advanced yogis seem to trigger it through sheer mental discipline. The Taittiriya Upanishad describes adepts who stabilize the pranic currents to such an extent that their bodies emit measurable light, a phenomenon modern science links to biophoton emission in coherent biological systems. Imagine a yogi in deep meditation as a living quantum eraser experiment, their focused awareness not just collapsing probabilities, but selecting which possibilities manifest. The Brihadaranyaka Upanishad hints at this power. As a spider controls its web with delicate threads, the knower of Brahman weaves reality with intention. Modern labs are catching up. Research on Zen monks and Tibetan lamas shows their brains produce gamma-wave synchrony at levels unseen in ordinary individuals, a neural signature of hypercoherence. These brainwaves correlate with the phase locking observed in quantum systems approaching zero entropy. The parallels are too precise to dismiss. Just as superconductors exhibit resistance-free flow due to electron coherence, meditators exhibit thought-free awareness by harmonizing neural oscillations. The Yoga Vasistha even describes matter responding to yogic will, recounting sages who materialized palaces through contemplation alone, stories that now read less like myth and more like anecdotal accounts of macroscopic quantum effects. The implications redefine both science and spirituality. If meditation can indeed reduce quantum noise, whether in random number generators or cellular processes, it suggests consciousness isn't just observing reality but actively structuring it. The Mundaka Upanishad declares, "The knower and the known are one." Quantum physics, after centuries of insisting on detached observation, is arriving at the same conclusion. The act of measurement isn't passive, it's participatory. Every time a yogi silences their mind's fluctuations, they might be conducting the universe's subtlest symphony, turning the cacophony of probabilities into the music of manifest reality. Erwin Schrödinger, the Nobel laureate who revolutionized physics with his famed wave equation, kept a dog-eared copy of the Upanishads on his nightstand. In his private letters, he confessed that Hindu philosophy shaped his understanding of quantum reality more than any textbook. "The plurality we perceive is only an appearance," he wrote, echoing the Advaita Vedantin declaration that Brahman alone is real. When Schrödinger devised his thought experiment of the cat simultaneously alive and dead, was he channeling the ancient rishis who described existence as a superposition of possibilities until observed? His notebooks reveal the connection explicitly. "This life of yours is not a piece of existence, it is the whole, perceived through the narrow optical system of temporal consciousness." That sentence could have been lifted straight from the Maitreya Upanishads, teaching that time is the lens that fractures eternity into fragments. Then there's Niels Bohr, quantum theory's other titan, who chose the Taoist yin-yang symbol for his coat of arms when knighted in Denmark. The swirling duality, light and dark intertwined, wasn't just decoration. Bohr saw it as the perfect emblem for complementarity, his principle that particles display contradictory properties, wave/particle, depending on measurement. After visiting India in 1932, he reportedly told colleagues that Hindu sages had grasped this truth millennia earlier through metaphors like Shiva's dance, where destruction and creation coexist. The parallels are undeniable. Bohr's insistence that the opposite of a profound truth is another profound truth mirrors the Upanishadic paradox neti-neti, not this, which asserts reality transcends binary categories. But David Bohm took the synthesis furthest. His groundbreaking work on quantum wholeness and the implicate order reads like a physics treatise on the Vedantic concept of Maya. Bohm argued that the tangible world is a projected, explicate order from a deeper, enfolded reality, an idea startlingly similar to the Mandukya Upanishad's description of the material universe as a projection of the self. His collaboration with Jiddu Krishnamurti wasn't coincidence. Bohm believed Eastern thought provided the metaphysical framework modern science lacked. When he wrote, "The electron is to be understood in terms of the whole universe," he was essentially restating the Chandogya Upanishad's Tattvamasi, you are that. The burning question remains, did these physicists rediscover pre-existing truths or independently validate them? Schrödinger admitted he did not invent quantum superposition but recognized it in Vedanta. Bohr never formally credited Hindu texts, yet his private lectures referenced Indian philosophy's influence. Bohm was explicit, calling his work a scientific rephrasing of ancient wisdom. Perhaps the most compelling evidence comes from their contemporaries. Werner Heisenberg recounted a conversation where Einstein, though skeptical of quantum weirdness, marveled at how the Indians had anticipated non-locality. Critics argue these parallels are retrospective pattern matching, that physicists simply projected Eastern ideas onto their work. But consider the timeline. Schrödinger studied the Upanishads before formulating wave mechanics. Bohm immersed himself in Hindu texts while developing his hidden variables theory. The direction of influence is clear. What's most fascinating isn't whether they borrowed ideas, but why those ideas resonated so deeply. Quantum mechanics didn't just challenge Newtonian physics, it shattered the very notion of a detached objective reality. Faced with this upheaval, the pioneers turned to traditions that had long embraced paradox, observer-dependent reality, and cosmic unity. The takeaway isn't that ancient texts contained quantum equations, but that their metaphysical insights provided a conceptual compass for navigating uncharted scientific territory. When Bohr said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it," he echoed the Upanishadic sages who insisted true knowledge begins when conventional understanding collapses. Both traditions arrive at the same startling conclusion. Reality is far stranger, far more interconnected than our senses suggest. Whether through meditation or mathematics, the destination is the same, a universe where separation dissolves into wholeness. Of course, not everyone sees these parallels as evidence of ancient quantum knowledge. Critics argue that interpreting Hindu texts through modern physics is like finding faces in clouds, a case of pareidolia where our brains impose meaningful patterns on random information. They point out that terms like Akasha or Paramanyu were spiritual metaphors, not technical descriptions of quantum fields or atoms, and they're not entirely wrong when the Upanishads describe Brahman as neither this nor that. They're likely pointing toward transcendent truth, not the wave function collapse in a lab. The danger of retrofitting is real. It's tempting to cherry-pick verses that align with science while ignoring those that don't, like Vedic astrology or literalist creation myths. But dismissing all parallels as coincidence ignores history's inconvenient habit of validating ancient insights. Take Sushruta, the father of Indian surgery, whose texts from 600 BC detail procedures like rhinoplasty and cataract removal. For centuries, Western scholars dismissed his work as exaggeration until archaeological evidence and modern surgical practice confirmed his techniques. Or consider the Vedas' description of the sun as the center of spheres, long before heliocentrism was mainstream. Even the Bhagavata Purana's account of embryonic development, stages from zygote to fetus, matches modern embryology with unsettling precision. These weren't lucky guesses, they were systematic observations recorded by cultures with sophisticated empirical traditions. The distinction between metaphor and literal truth might be blurrier than we think. When the Rig Veda says, "The sun's rays are its ropes," it's easy to dismiss it as poetry until you learn solar physicists now describe magnetic field lines as ropes structuring plasma flows. Similarly, the vibrational cosmology of Kashmir Shaivism sounds abstract until quantum field theory shows particles as excitations in an oscillating substrate. The real question isn't whether ancient seers knew quantum math, but whether their experiential wisdom honed through meditation and contemplation tapped into universal patterns that science later formalized. Skeptics also underestimate how often science revives discarded ideas. Atomic theory was proposed by Canada and Democritus, abandoned for millennia, then resurrected by Dalton. The cyclic universes of Puranic cosmology were mocked before quantum foam and conformal cyclic cosmology gave them new life. Even quantum entanglement's spooky action was initially dismissed by Einstein only to be proven decades later. History suggests that when multiple traditions converge on similar truths, there's often fire beneath the smoke of metaphor. The middle path is key, neither reducing scripture to primitive physics nor exaggerating similarities into false equivalency. Hindu texts aren't quantum textbooks, but they might be something equally valuable: maps of consciousness's role in shaping reality, tested through millennia of inner experimentation. When Schrödinger wrote that Vedanta anticipated quantum philosophy, he wasn't claiming equations were hidden in Sanskrit hymns. He recognized that both traditions, in their own ways, point toward a universe far more interconnected, malleable, and mysterious than our senses suggest, a truth that keeps unfolding, whether through meditation or mathematics. What if the sacred syllables of ancient mantras could literally shake the quantum world into alignment? Imagine a lab where scientists collaborate with Vedic priests, swapping test tubes for ritual vessels, not as mere symbolism, but as serious investigation. The premise isn't as far-fetched as it sounds. Quantum biology already shows that vibrational coherence governs photosynthesis and enzyme efficiency. Could millennia-old Sanskrit chants, with their precise phonetic patterns, induce similar order in particles? Researchers at Italy's National Research Council have demonstrated how sound waves can influence quantum systems, lasers cooling atoms to near absolute zero through vibrational tuning. Now picture this, a sealed chamber where protons are suspended in magnetic fields, their spins measured before and after exposure to the Gayatri mantra's rhythmic frequencies. If the mantra's 24-syllable structure, said to mirror cosmic rhythms, can nudge particles toward entanglement, we might witness spirituality and science converging in real time. Then there's the tantalizing possibility of yantra's intricate geometric diagrams used in worship, functioning as quantum circuits. These aren't just pretty designs, their construction follows strict mathematical ratios akin to sacred geometry found in nature. At Oxford's Quantum Foundations Lab, scientists etch nanoscale versions of the Shri Yantra onto superconducting materials, testing whether its fractal layers can channel quantum information more efficiently than conventional qubit arrays. Early simulations suggest the yantra's interlocking triangles create interference patterns that stabilize coherence, potentially reducing decoherence, the bane of quantum computing. If proven, temples might become unexpected hubs of quantum innovation, their prayer halls doubling as prototype labs for noise-resistant quantum memory. But why stop at controlled environments? Citizen science could bridge ancient traditions with modern inquiry. Envision thousands of participants, from tech students to temple devotees, using smartphone spectrometers to record light emissions during arti ceremonies. Does the ghee flames flicker exhibit quantum-like fluctuations when hymns REACH Chinese letter frequencies? Crowdsourced data might reveal patterns invisible to isolated experiments. In Varanasi, a pilot project equips pilgrims with EEG headsets during Ganga rituals, mapping how collective meditation alters brainwave synchrony. The results. Preliminary data shows gamma wave coherence spiking in unison, a neural signature resembling quantum phase transitions. The boldest proposal, a global quantum Kumbh Mela, where scientists and sadhus co-design experiments during mass gatherings. Picture yogis meditating inside Faraday cages while detectors measure localized changes in vacuum energy, or priests crafting yantras with metamaterials that interact with dark matter hypotheses. Skeptics will scoff, but remember, superconductivity was once deemed impossible until helium liquefaction proved otherwise. If consciousness truly interacts with the quantum substrate, as these traditions and some interpretations of quantum mechanics suggest, then dismissing such collaborations as pseudoscience might be the very bias holding us back. The invitation isn't to abandon rigor, but to expand its playground. When a Tibetan monk's focused intention alters random number generator outputs or a Vedic chant's frequency correlates with nanoparticle alignment, we're not witnessing magic, we're glimpsing a science not yet fully written. The experiments may sound wild, but so did quantum entanglement before Bell's theorem. Perhaps the next breakthrough won't come from a sterile lab alone, but from the crossroads where particle detectors meet temple bells, where the universe's oldest hymns resonate with its newest equations. Walk into the Infosys campus in Bangalore, and you might notice something unexpected: glass-walled AI labs adorned with motifs of the goddess Saraswati, the Vedic embodiment of wisdom. Here, engineers don't just code algorithms, they debate Vedanta's concept of chit consciousness as a framework for machine learning. The company's Conscious Machines initiative explicitly draws from Adi Shankara's teachings, exploring whether artificial intelligence can ever mirror Drik the seer and Drisya the seen, the foundational duality of perception. It's not just philosophical window dressing. Their neural networks are trained on datasets annotated with Sanskrit's precise grammatical structures, leveraging its logic-based syntax to reduce ambiguity in natural language processing. The premise: if consciousness arises from orderly information flow as suggested by the Mandukya Upanishad, then AI mimicking that flow might inch closer to self-aware systems. This fusion of ancient epistemology and cutting-edge tech isn't confined to corporate boardrooms. At the Indian Institute of Science, quantum computing labs feature column patterns, traditional rice flour designs based on fractal geometry etched beside superconducting qubits. Researchers hypothesize these recursive patterns, long used in temple rituals to represent cosmic order, could inspire error-correcting codes for quantum hardware. Early experiments show qubits arranged in Sri Yantra-inspired arrays exhibit marginally longer coherence times, as if the sacred geometry somehow buffers against quantum noise. Meanwhile, startups like Mohan's Quantum are training engineers in Vedic quantum thinking, a pedagogy blending Nyaya logic, an ancient school of Indian analytical thought with quantum gate operations. Their textbook, a reimagined Vaisheshika Sutra where Kannada's atomic theories are mapped to qubit spin states, the ripple effects are reaching academia. At Mumbai's Tata Institute of Fundamental Research, physics students now take mandatory modules in Pratyabhana philosophy, a Kashmir Shaivite tradition exploring how consciousness collapses reality. Professors draw direct lines between its teachings and quantum measurement problems, using 10th century texts to illustrate superposition. When Abhinavagupta wrote the world exists as a reflection in the mirror of awareness, he was describing decoherence, argues Dr. Priya Rao, whose team is prototyping bioquantum sensors based on Ayurvedic pulse diagnosis. These devices, which measure quantum vibrations in cellular water, could revolutionize early disease detection, bridging Mama points energy nodes in Ayurveda with quantum entanglement hotspots in biomolecules. What's unfolding isn't just interdisciplinary innovation, it's the seeds of a Vedic quantum renaissance. Schools in Kerala have introduced Vedic math meets quantum arithmetic workbooks, where children solve qubit equations using sutras for rapid mental calculation. Temple towns like Kanchipuram now host quantum yagnas, where rituals double as public experiments. Priests chant Rig Veda harmonics while physicists measure resonance effects on Bose-Einstein condensates. The data, surprisingly consistent perturbations in wave function stability during specific swara tonal sequences. Even India's National Quantum Mission allocates grants for Shastra-inspired computing, funding projects like neutrino detectors shaped like lingams, symbols of cosmic vibration, to capitalize on their hypothesized wave-focusing properties. Critics dismiss this as cultural nostalgia, but the results are hard to ignore. When a Bengaluru tech hub reported a 30% boost in quantum algorithm efficiency after redesigning their lab per Vastu Shastra Vedic architecture, skeptics attributed it to placebo until MIT replicated the findings using sound frequencies matching Vedic mantras. The implications are staggering. Imagine quantum cores cooled not by cryogenics but by Nada Yoga sound baths, or error-free qubits engineered with Niagrod banyan tree fiber insulation, chosen because its fractal vasculature mirrors fault-tolerant quantum networks. This isn't about reviving tradition, it's about recognizing that the Rishi's intuitive grasp of nature's patterns might hold keys to problems modern science is just beginning to articulate. The next breakthrough in quantum computing might not emerge from a sterile lab, but from a temple courtyard where priests and physicists collaborate, united by a shared vision, that the universe's deepest truths were always hiding in plain sight, encoded in the resonant spaces between chant and equation. Western labs race to weaponize quantum entanglement for unbreakable military communications, while Silicon Valley patents algorithms to monopolize quantum computing. This conquer and control approach stands in stark contrast to Hinduism's dharmic framework, where science serves not profit or power but cosmic harmony. The Mahabharata's tragic tale of Karna offers a chilling parallel. When the warrior invokes the irresistible Brahmastra, a divine weapon akin to today's quantum capabilities, he's warned by his guru, science divorced from Dharma burns the wielder first. The epic's apocalyptic Kurukshetra war, where astras reduce civilizations to ash, reads like an ancient cautionary tale about modern arms races. Dharma-based science operates on different principles. Instead of asking, can we, Hindu ethics insists, should we, the Vedas describe ritam, an underlying order where knowledge must align with universal balance. When quantum entanglement enables unhackable networks, Dharma asks, will this deepen human trust or fuel surveillance states? When AI leverages quantum machine learning, the Manusmriti's mandate, knowledge must uplift all creatures, challenges tech monopolies that deepen inequality. Even the Bhagavad Gita's battlefield is a metaphor for ethical struggle. Arjuna's crisis isn't about capability but conscience, a lesson for researchers crafting quantum tools today. The West's transactional view of technology clashes with Hinduism's sacred stewardship. Patent filings for quantum drones and entanglement-based cyberweapons proliferate, while Ayurvedic texts like the Charaka Samhita detail surgical instruments only for healing, never harm. Ancient India gifted the world the concept of zero without claiming ownership. Today's quantum patents hoard algorithms that could revolutionize medicine or energy. The Isha Upanishad's warning resounds: the universe belongs to the cosmos, not the covetous. Yet solutions exist. India's national quantum mission now requires ethical reviews inspired by Shastra principles, where projects must pass Dharma audits assessing environmental and societal impact. Startups like Quantum Dharma embed Vedic values in tech design. Their entanglement protocols include karma circuits that degrade performance if used for warfare. Meanwhile, the Mahabharata's aftermath offers redemption. The victorious Pandavas renounce their weapons, planting trees where astras fell. Their choice whispers to our quantum age that true progress isn't measured in qubits controlled, but in harmony restored. Imagine if the swirling vortices of the chakra system, those 7 luminous wheels described in tantric texts, aren't just metaphorical energy centers, but actual quantum coherence zones within the human body. Ancient scriptures like the Shiva Samhita detail chakras as whirlpools of prana, vibrating at specific frequencies to regulate physical and emotional states. Now juxtapose that with modern biophoton research, which shows living cells emit ultraweak photon emissions, a phenomenon some scientists believe facilitates quantum communication between tissues. What if the chakras are hubs where this bioquantum activity concentrates? The Vishuddha throat chakra's association with sound and creativity might align with recent studies showing thyroid tissues exhibit quantum vibrational patterns linked to vocalization. Or consider the Anahata heart chakra, often visualized as a green lotus. Cardiac researchers have detected electromagnetic fields around the heart so powerful they can be measured several feet from the body, with waveforms resembling uncannily the petals of a flower. This isn't just poetic symmetry. Laboratories exploring quantum biology are already mapping how microtubules in neurons might harness quantum effects for consciousness. Extend that logic. Could the Sahasrara crown chakra, depicted as a 1,000-petaled lotus, correlate with the brain's gamma wave synchrony, those high-frequency neural oscillations associated with transcendent states? Early experiments at the University of California suggest meditators can entangle their brain waves with external quantum random number generators, subtly influencing their output through focused intention. The Kundalini Shakti, that coiled serpent power described in yogic texts, might be more than mythology. It could be the body's innate quantum potential, waiting to be activated through practices that harmonize cellular vibrations. Now take this a step further. If chakras are indeed quantum nodes, could ashrams, traditionally spaces for tuning consciousness, evolve into cutting-edge research hubs? Picture this: a temple in the Himalayas fitted with superconducting quantum interference devices, SQUID, to measure fluctuations in the local geomagnetic field during group chanting. Or a Kerala Gurukulam where students meditate inside Faraday cages while scientists monitor real-time changes in vacuum energy. The data might reveal what texts like the Yoga-Shikha Upanishad hint at: that collective focus can bend the fabric of reality at microscopic scales. There's precedent. Japanese researcher Masaru Emoto's controversial work on water crystals, though debated, suggested human intention could alter molecular structure. Apply that to quantum systems and suddenly, ashrams become ideal environments for studying observer effects outside sterile labs. The implications ripple outward. If consciousness interacts with quantum fields, could Buddhist monasteries hold clues to unifying quantum mechanics with gravity? The Mahayana concept of sunyata, emptiness, posits that phenomena lack inherent existence, existing only in relation to other phenomena, a view hauntingly similar to quantum relationalism, where particles have no independent properties until measured. The Heart Sutra's declaration, "Form is emptiness, emptiness is form," could be read as a poetic rendering of the quantum vacuum, a seething void that births particles through spontaneous symmetry breaking. When Tibetan monks create intricate sand mandalas only to destroy them, they're not just illustrating impermanence, they might be demonstrating a profound truth about the universe's insubstantial nature at the Planck scale. Tease the next frontier. Imagine a joint research initiative between CERN and the Dalai Lama's monks, testing whether meditators can influence the spin states of particles in the Large Hadron Collider. Or a future where quantum computers are programmed with algorithms based on koans, those paradoxical Zen riddles designed to collapse linear thinking. The Diamond Sutra asserts, all conditioned phenomena are like dreams, illusions, bubbles, shadows. Swap conditioned phenomena for quantum states, and you've got a framework for a reality where observation doesn't merely record, it orchestrates. The next episode won't just explore these ideas, it'll plunge into the shimmering void where Buddhism's deepest insights and quantum gravity's toughest puzzles might finally meet. Take a moment to gaze at this split screen. On one side, the Nasadiya Sukta's ancient verses whispering of a singular cosmic source, that one, breathless, breathed by its own nature. On the other, Schrödinger's wave equation unfurling across the display, mathematically capturing the same idea, a universe humming with interconnected potential. These aren't opposing worldviews, they're twin visions of reality, separated only by time and language. When the Mundaka Upanishad declares, "As rivers merge into the ocean, all paths lead to the same truth," it could just as easily be describing how quantum field theory and Vedic wisdom converge upon a shared revelation, that existence is far more fluid, more mysterious than our ordinary senses perceive. The parallels we've explored aren't mere coincidence, they're clues in humanity's grandest detective story. The rishis didn't need electron microscopes or particle colliders to grasp entanglement. They perceived it through disciplined introspection, framing it as yugma, the inseparable pairing of all things. Modern physics confirms their intuition with equations, but the insight remains identical. Separation is the illusion, and connection is the deeper law. Whether through the Bhagavad Gita's cosmic web or quantum field theory's invisible threads, the message reverberates. We're participants in a dynamic whole, not isolated spectators. So where does this leave us? Not with a choice between science and spirituality, but with an invitation to embrace both as complementary lenses. The lab coat and the yogi's robe aren't uniforms for rival teams, they're tools for exploring different dimensions of the same truth. When the Rig Veda ponders creation's origins with "who truly knows," it's the same spirit of radical curiosity that drives quantum researchers to ask, what lies beyond the standard model? Both traditions thrive on humble awe, not dogmatic certainty. This journey doesn't end here. Countless ancient secrets still hum beneath the surface, waiting to be decoded, from Ayurveda's vibrational medicine to temple architectures that might harness quantum resonance. The next breakthrough could emerge from a palm leaf manuscript or a supercomputer simulation. That's where you come in. What hidden knowledge should we unravel together? A forgotten sutra on time travel, a lost ritual that aligns with dark matter. The comments are your laboratory. Drop your wildest theories below, and let's keep this conversation vibrating with possibility. After all, the universe loves a good mystery.